In this lesson you will learn how to solve the two special right triangles. The first triangle we'll look at is the 45-45-90 triangle. So in this triangle, the sides that are across from the 45 degrees are both equal to x. The side across from the hypotenuse is equal to x root 2. So in this triangle below, if I had labeled this side 4, that means across from 45 degrees is 4. Across from this 45 degrees will also be 4. But then across from the hypotenuse would be 4 root 2. So this 4 corresponds with this x. So x is automatically 4, and every x in this triangle is equal to 4. So you just replace each of the x's with 4 once you find the value of x. The next of the two special right triangles is the 30-60-90 triangle. And what's different about these two triangles is that in the first one I put the 30 degrees on top, but in the second one I put the 30 degrees on the bottom. So across from 30 degrees is x. Across from 60 degrees is x root 3, and across from 90 is 2x. So if I label this side 4, across from 30 is 4, which means across from 60 is 4 root 3, and across from 90 is 8. So once I've identified all of the x's to be 4, then they all get replaced with the value of 4. So in this triangle, I'm now going to put the number 7 here, and 7 is across from 30. So across from 30 is x. So that means that x is equal to 7. So I replace this x with 7 to get 14, and this x to be 7, so I get 7 root 3. So across from 90 is 14. So this side is 14. Across from 60 is 7 root 3. So this side is 7 root 3. So your goal in solving special right triangles is to identify the x. Once you've identified x, all of the x's in the triangle get replaced with that value. So the directions are to find the missing sides of the right triangle. And the first thing you want to do for all of these questions is you want to draw the reference triangle each time. Drawing it each time will help you memorize it. So in the 45-45-90 triangle, the two legs are equal to x, and the hypotenuse is equal to x root 2. So if I look at what's given, this number 5 is across from 45 degrees. So across from this 45 degrees is x. So that means that x is equal to 5. So once you identify the x, all of the x's in the reference triangle get replaced with 5. So this side is 5 root 2. This side is 5, that was given, and this side is 5. So the missing sides of the right triangle are 5, 5, and 5 root 2. So for number 2, we have another 45-45-90 triangle. So I draw the reference triangle again, and I label the legs as x, the hypotenuse as x root 2, and I look at what's given, this side, which is across from 45 degrees, which corresponds to this side, and that's labeled as x. So that means that x is equal to 7. So once you identify your x, you replace all of the x's in the reference triangle with that value. So you have 7, 7, and 7 root 2. So for number 3, another 45, 45, 90 triangle. And we have x, x, and x root 2. And this time, when I look at the triangle that's given, we're given the side across from the 90. And the side across from the 90 is x root 2. So I take x root 2 and I set it equal to 12 root 2 and solve for x. So if I'm solving for x, I want to divide both sides by root 2. And when I divide both sides by root 2, they cancel, and I'm left with x equals 12. So all of the x's in the reference triangle get replaced with the number 12. So I have 12, 12, and 12 root 2. For number 4, ABCD is a square, and what we know about squares is that we have 4 right angles and 4 equal sides. So all 4 sides are equal to 8. We're looking to find the length of BD, which is right here, and in a square, the diagonal divides the square into two 45, 45, 90 triangles. So that means we're dealing with a 45, 45, 90 triangle again, and when I draw my reference triangle, I just draw it the same orientation as the one that's given. So we have 45, 45, 90, and then x and x for the two legs, x root 2 for the hypotenuse, and I see that the 8 is in place of the x, so x is equal to 8. We have an 8 on the bottom, and the hypotenuse is 8 root 2. So the hypotenuse is the diagonal. So when the question asks for the length of BD, BD is equal to 8 root 2. For number 5, find the area and perimeter of square ABCD. To find the area of a square, area is equal to side times side, and the perimeter is equal to 4 times the length of each side. And in a square, we know that we have 4 right angles and 4 equal sides. We also know that the diagonal divides a triangle into two 45, 45, 90 triangles. So that means that we'll need our reference triangle as the 45, 45, 90 triangle. The legs are both x, and the hypotenuse is x root 2. So what's given is the hypotenuse, 3 root 2, which is across from x root 2. So my goal is to solve for x. So if I take x root 2 and set it equal to 3 root 2, I divide both sides by root 2, so that both root 2's cancel, and I get x is equal to 3. So that means this x is 3, this x is 3, this one we already knew was 3 root 2, and since it's a square, we know that all four sides are 3. So when I find my area, it's equal to 3 times 3. So the area is equal to 9. When I find the perimeter, it's 4 times the length of each side, so 4 times 3, so the perimeter is equal to 12. For number 6, now we'll move on to the 30, 60, 90 triangle. And what's really important with the 30, 60, 90 triangle is that you have your 30 and 60 in the proper place. So in the given triangle, we have the 60 on top. So you want the 60 to be on top in your reference triangle and the 30 to be on the bottom. Always across from the 30 is your x. Always across from the 60 is x root 3. Always across from the 90 is your 2x. So I look at my given triangle, and across from 30 I have 2. So in my reference triangle, across from 30 I have x. So that means that x is equal to 2. And I replace 2 with all of the x's in my reference triangle. So I have 2, 4, and 2 root 3. Once you identify your x, it gets replaced with all of the x's in your reference triangle. Now for number 7, it's still a 30, 60, 90 triangle, but what's different about this problem is that now the 30 is the top angle. So I place the 30 here, and now 60 goes on the bottom. Across from the 30-degree measure is your x. Across from the 60 is x root 3. Across from the 90-degree, or your hypotenuse, is 2x. Now I look at what's given, and across from 60 is the angle that's given, or the side that's given. Across from 60 is x root 3. So I take x root 3, set it equal to 8 root 3, divide both sides by root 3, so that the root 3's cancel, and I'm left with x equals 8. So this side is 8, this side is 16, all of the x's get replaced with 8, so the missing sides are 8 and 16. So for number 8, another 30, 60, 90 triangle. 30 is on top, so 30 goes on top, 60 on the bottom. Across from 30 is x, across from 60 is x root 3, and the hypotenuse is 2x. So every time you have a question that involves the special right triangles, you want to draw the reference triangle each time, and that will help you memorize it. 10 is given, and 10 is across from the 90. Across from the 90 in our reference triangle is 2x. So if 2x is equal to 10, and our goal is to solve for x, that means that x is equal to 5. So a 5 goes here, and for all of the x's in the reference triangle. So we have 5 on the bottom, and then 5 root 3 on the side. So for number 9, we're asked to find the altitude of equilateral triangle ABC. And the altitude is this length here. So first let's look at properties of an equilateral triangle. In an equilateral triangle, we have 3 equal sides and 3 equal angles. And if we take 180 degrees and divide it by 3, we get 60 degrees. So that means that each of the angles in triangle ABC are 60 degrees. But because we have an altitude drawn, it divides 60 by 2 so that each side is 30. We know that all three sides are 32 because an equilateral triangle has equal sides, but this altitude splits it up into 16 and 16. So I've solved almost everything of this triangle except the altitude. So what I'm going to do is I'm just going to work with this side of the triangle. So I'm just going to take that side and redraw it down below so that we have 30, 60, 90 triangle. 16 we already know is on the bottom, and 32 is the hypotenuse. And then next to this, I'm going to draw my reference triangle. The reference triangle is the one that has the x's. I want my 30 on top. X is across from 30. X root 3 is across from 60. And 2x is the hypotenuse. So I can start with either the 32 or the 16. I'm going to start with a smaller number, the 16, and across from 30 is x. That means that x is 16. So if x is 16, we know 2 times 16 is 32, and x root 3 is 16 root 3. So 16 root 3 is the length of our altitude. For number 10, we want to find the area and perimeter of equilateral triangle ABC. So the area of a triangle is equal to 1/2 times the base times the height, and the perimeter is equal to 3 times For number 10, we're asked to find the area and perimeter of equilateral triangle ABC. So to find the area of a triangle, it's equal to 1/2 times the base times the height, the perimeter is equal to 3 times For number 10, we want to find the area and perimeter of equilateral triangle ABC. So to find the area of a triangle, the formula is 1/2 times base times height, and the perimeter is equal to 3 times the length of each side. So again, with an equilateral triangle, we know that we have 3 sides that are equal and 3 angles that are equal to 60 degrees. So all of the sides are equal to 14. So before we go any further with this, we can find the perimeter as 3 times 14 and 3 times 14 is 42, so we've already found our perimeter. So going back up to our triangle, again, an equilateral triangle has 3 equal sides and 3 equal angles. All 3 angles are equal to 60 degrees. So to find the area, the formula is 1/2 base times height. Our base is the length from A to C. So the base is 14. The height is this length here. Another word for the height is the altitude. So if I take this triangle and redraw it on the side, I have a 90-degree angle here and a 60-degree angle here, which means that that 60 on top is bisected to 30. And our 14 is the length of each side of that triangle. And next to this, I'll draw my reference triangle. Side across from 30 is x, side across from 60 is x root 3, and the hypotenuse is 2x. So I match up the 14 with 2x, and since 2x is equal to 14, then I know that x is equal to 7. So we have the bottom side is 7, this side is 7 root 3, and if I match it up, I have this length as 7 root 3. And that 7 root 3 is my height. So now I have all the values that I need to find the area. So area is 1/2 times the base, which is 14, and then times the height is 7 root 3. So because I have fractions here, I'm going to put the 14 over 1 and the 7 root 3 over 1 so that I can reduce the 2 with the 14 and make it a 7, and then 7 times 7 root 3 is 49 root 3. The last problem, number 11, we have a room is in the shape of a regular hexagon with each side equal to 12 feet. So a hexagon has 6 sides, and when it's regular, it means that all 6 sides are equal and all 6 angles are equal. So here's my regular hexagon, and I know that each side is equal to 12. We want to find the distance between 2 opposite walls of the room, and then we want to round our answer to the nearest whole number. So 2 opposite walls of the room would be this length. So this is the length that we're looking to find. And the center of this hexagon is right about here. So from the center, if I were to draw 6 lines to each of the vertices of this hexagon, it would look like this. So since I formed 6 triangles, and we know that there are 360 degrees in a circle, 360 divided by 6 is equal to 60 degrees. So that means that I have 60 degrees here, 60, and then because this red line bisects it, we have 30, 30, and then 2 30s down here. So we need to find the length of just half of this red line that we drew, and then double it to find the total length. So let's look at this triangle here and draw it on the side. So we have 30 degrees up here, That means 60 degrees will have to be on the bottom. And if this whole length is 12, then half of it would have to be 6. So now that I have one side of my triangle, I want to draw the reference triangle next to it so that I have a 30, 60, 90 triangle. Across from 30 is x, across from 60 is x root 3, and the hypotenuse is 2x. I match up 30 with 6, so 30 matches up with x, and I know that x is equal to 6. So this length is 12, and this length is 6 root 3. So I apply it to my triangle, and I have 12 and 6 root 3. So if we change colors again, 6 root 3 is this length right here, which is also this length right here. So if we're looking for the distance between two opposite walls, here's one wall and here's another wall, then the distance is equal to 6 root 3 plus 6 root 3, which is equal to 12 root 3. And if you take 12 root 3 and put it in your calculator, you'll get 20.7846. But because we want to round this to the nearest whole number, we would round this up to 21. And the unit that was given in the beginning of the problem was in feet, so the distance rounded to the nearest whole number is 21 feet.